Hi friends, so let's look at some of the problems which can be solved using trigonometric identities. So whenever you want to solve trigonometric identities problems, you have to remember the identities which are as below. So cos squared a plus sin squared a equal to 1, that is one identity. 1 plus tan squared a is secant squared a, and 1 plus cot squared a is cosecant squared a. Okay, tan a is sin a by cos a, secant a is 1 upon cos a, cosecant is 1 upon sin a, and cot is 1 upon tan. So all these trigonometric identities you should always remember. Okay, now let's look at the problem. We are given sin a is 3 by 4. What is cos a and what is tan a? See, whenever you are given sine and you want cos, you need to think which identity I can use to solve this. So if you look at this identity, you are given the sine, you want the cos, so you can definitely use this identity. Okay, so we know that sin squared a plus cos squared a equal to 1. So cos squared a is equal to 1 minus sin squared a, right? Sin a is given to be 3 by 4. So sin squared a is nothing but 3 by 4 whole squared. Okay, so that is 3 3s are 9, 4 4s are 16, 1 upon 9 by 16. Okay, now 1 is 1 upon 1, and the denominator is 1 here and it is 16 here, so you have to take the LCM. So if you multiply this by 16, denominator by 16 and the numerator by 16, you can say denominator becomes the same, that is taking a LCM, and you can say that 16 minus 9, that is equal to 7 by 16. Okay, so you must make both the denominators the same by taking an LCM, which is 16. So numerator becomes 16 and numerator here becomes 9. So 16 minus 9 is 7. 7 by 16 is sin squared a. So cos squared a. Okay, so cos a is root of 7 by 16. Okay, so square root of 7, and below in the denominator square root of 16, you will get it as 4. Okay, then tan a, we are being asked to calculate tan a, that is nothing but sin by cos. So sin a we know is 3 by 4, we substitute, divided by cos a, we can see that we have calculated it as root 7 by 4, that we substitute here. So that equal to, so since this is a division and this is a fraction, this fraction gets inverted, the 4 goes up, root 7 remains down, and this becomes a multiplication. The 4 and 4 gets cancelled and you get 3 root 7. So tan a is equal to 3 root 7. So given one trigonometric value, we are able to calculate the other two trigonometric values. Okay, so let's look at the other problem, next problem. So given secant theta is equal to 13 by 12, calculate the other trigonometric identities, and again we have to use identities to solve this problem. Okay, so given that secant theta, we know that secant is nothing but 1 over cos, or cos is 1 over secant. Okay, so when we substitute for secant theta, which is 13 by 12, we get cos theta is equal to inverse of 13 by 12, that is 12 by 13. Okay, now we have sin squared theta plus cos squared theta equal to 1, right? Sin squared theta is equal to 1 minus cos squared theta. So we got cos theta, we want sin theta, so we are using this identity and substituting for cos theta. So we get 1 minus 12 by 13 whole squared. Okay, what is 12 squared? 144. What is 13 squared? Use your calculator, you will see it is 169. Okay, once we take the LCM, the denominator will become 169, the numerator here also will become 169, the 144 will remain as it is. So we are getting 169 minus 144 divided by 169. Okay, which is equal to, if you again use a calculator, 169 minus 144, you will get 25. Okay, so 25 by 169. So sin squared theta is 25 by 169, which implies sin theta is square root of 25 by 169. Square root of 25 is 5, and denominator square root of 169 is 13, so we get 5 by 13. Okay, so we got the cos theta, we got the sin theta, we can get the tan theta by doing sin by cos as we did before, which is 5 by 13 divided by 12 by 13, substituting from here and here. Okay, again since this is a division and this is a fraction, it will get inverted. So 13 by 12, 5 by 13 into 13 by 12, 13 cancels, we get 5 by 12. Okay, And cosecant theta is equal to 1 upon sine theta, that is 1 upon 5 by 13, that is 13 by 5. And cot theta we know as 1 by tan theta, that is 1 upon 5 by 12. Okay, tan theta we have already calculated here, 5 by 12. So cot theta is 1 upon tan theta, that is 12 by 5. Okay, so these are the problems using trigonometric identities. Okay, so let's look at the next problem. We have cot theta is equal to 7 by 8. We need 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta in the denominator is equal to what? And cot square theta is equal to what? Okay, so remember from your previous classes that a plus b into a minus b is equal to a squared minus b squared. Okay, so in the numerator 1 plus sine theta into 1 minus sine theta becomes, you know, a squared. In this case, instead of a we have a 1, and b squared, instead of b we have sine theta, correct? So you'll get minus sine squared theta. Okay, and we know trigonometric identity that sine squared theta plus cos squared theta is 1. So 1 minus sine squared theta means if you take this sine squared theta to the other side, you'll get cos squared theta. So you have cos squared theta, correct? Similarly, 1 plus cos theta into 1 minus cos theta is 1 minus cos squared theta. So if you take cos squared theta to the other side, you will get sine squared theta. So 1 minus cos squared theta, you can write it as sine squared theta. Okay, so for the first case, LHS, that is the left hand side of the expression which is to the left of the equal to sign, you will get, in the numerator you will get cos squared theta, in the denominator you will get sine squared theta. Okay, which is nothing but cos theta by sine theta whole squared, because square is there here also, square is there here also. Okay, so what is cos theta by sine theta? It is cot theta. Okay, cot theta whole squared. So cot theta is 7 by 8, it is given. When we do whole squared, we get 49 by 64. Okay, so for cot squared theta, we can substitute it easily, and cot theta, when we substitute 7 by 8, we get 7 by 8 whole squared, which is nothing but 49 by 64. So in both of these cases, the answer is same, which is 49 by 64. Okay, so let's look at the next problem. They are saying if 3 cot a equal to 4, check if 1 minus tan squared a divided by 1 plus tan squared a is equal to cos squared a minus sin squared a. That is, they are saying check if the left hand side, which is 1 minus tan squared a divided by 1 plus tan squared a, is equal to the right hand side. Which is the right hand side? Cos squared a minus sin squared a. Okay, so given 3 cot a equal to 4, cot a will be 4 by 3. Okay, tan a will be equal to 1 by cot a. Correct. See, we have cot a and we want tan a. So we have to go from cot a to tan a. Correct. So we know that tan a is 1 by cot a. So cot a is 4 by 3. So tan a is 1 by 4 by 3, which is 3 by 4. Okay. So since we know the tan a now, that we can substitute in the numerator and denominator. Okay. So also 1 plus tan a is equal to secant squared a. That identity also we know, right? Which is equal to 1 plus 3 by 4 whole squared, because tan a is 3 by 4 we have calculated. So 9 by 16, again taking the LCM and adding, you'll get 16 plus 9 by 16, which is 25 by 16. So secant squared a is 25 by 16. So secant a is equal to root of 25 by 16, correct? So root of 25 is 5, root of 16 is 4. So cos a is equal to 1 over 5 by 4, that is 4 by 5. Why? Because cos a is nothing but 1 upon secant a. So secant a is 5 by 4, so we get 4 by 5 here. Okay, so we need sin a, so we can use sin squared a plus cos squared a equal to 1. So you can see that the sin squared a is equal to 1 minus cos squared a. Why? Because we took this cos squared to the other side and we substitute the for cos here. Okay, we get 1 minus 16 by 25. So you take the LCM, take the 25 to the numerator also. 25 minus 16 is 9. So sin squared a is 9 by 25. So sin a is square root of 9 by 25. Square root of 9 is 3. Square root of 25 is 5. So you get 3 by 5. So after all this, you know, you got the sin a, which is 3 by 5. You got the cos a, which is 4 by 5. So we know that tan A is 4 by 5, 3 by 5 divided by 4 by 5, that is 3 by 4. Okay, so in this case, for the LHS, 1 minus tan squared A divided by 1 plus tan squared A, we can easily substitute here. 1 minus 3 by 4 whole squared divided by 1 plus 3 by 4 whole squared, right? So 3 squared is 9, 4 squared is 16, so you'll get 1 minus 9 by 16, 1 plus 9 by 16. Again, if you want to subtract or add, you need to have the same denominator, so you need to take the LCM. So you get 16, 16 minus 9, 16 plus 9 divided by 16, okay? So 16 minus 9 by 16 is 7 by 16. Here you have the division, so this 16 will go up, and this 16 plus 9 is 25, it will come down here. You cancel this 16 and 16, and 7 by 25 remains. Okay, that is your left hand side. What about your right hand side? See, right hand side you need cos and sine, cos squared A and sine squared A, but we have already calculated that. See, we have already calculated cos A is 4 by 5 and sine A is 3 by 5. So you can substitute now. Cos squared A is 4 by 5 whole squared minus sine squared A, which is 3 by 5, like we have calculated here, 3 by 5 whole squared. So what is that? It is 16 by 25 minus 9 by 25. Okay, in this case both the denominators are the same, so you don't need to take LCM because they both are same. So 25 minus 16 by 9, you will get 7. Okay, so 7 by 25 here also, 7 by 25 here also. So LHS is 7 by 25, RHS is equal to 7 by 25, so LHS is equal to RHS. Okay, so this problem is solved like this using trigonometric identities.